Welcome to Future Foodcast. I'm Pam Line-Miller, your host. Excited to bring this episode to you. Thank you to our sponsor, Farm to Plate. They are developing tomorrow's food business ecosystem today. You can find out more at farmtoplate.io. Excited to bring a really interesting topic to you we have not discussed on this podcast before. I have with me Javi McGuiggan. She is the Global Director for Power Systems for Cargill Bio Industrial. Welcome to the podcast, Javi.
Thank you so much for having me.
I know I'm just looking forward to bringing all this information to our audience because I think a lot of us, and me for one, have no idea that initiatives like the ones that you're working on are going on. So why don't you just jump in and tell us a little bit about what you do at Cargill?
So Cargill, for those that might not know about Cargill, no, this is a food podcast, so the majority of the people might know, is a giant food company, a private food company. But what they did through the years is develop this business unit called Bioindustrial, which takes the elements that come from nature and other businesses, right, like oils or starches, and they turn them through chemistry into industrial solutions, so industrial used products, not for food, and those are in several applications. So that's based of Cargill's Bioindustrial business where I work. I lead a couple product lines there that I'll tell you more about, but the base of the business is taking these renewable resources and turning them into an industrial application that can either replace a petrochemical-based solution or a harsh chemical, like something toxic. This is replaced by our solutions.
Yeah, so essentially you are really trying to innovate alternatives to some of the more harmful things that we've been using. And now that we're trying to look at being kinder to the environment and to ourselves.
Renewable resource, more sustainable sources, greener ingredients.
Yes, and all of that. And I mean, there's lots of positives to go on here. So what are the initiatives that you're working on in particular? You mentioned you had a couple.
Yes, so there's different types of things that Bioindustrial is working on. Some of those initiatives are just adding some of these renewable plant-based ingredients to some normal applications. Like there's a whole business that we call beauty, which put these ingredients in creams and lotions and personal care products. There's other that put it in applications like asphalt, foams, plastic, candles, many, many more. In particular, the ones that I lead are two oil-based, soybean oil-based products. One goes inside of transformers as a dielectric fluid. So it's an insulator within a transformer unit. And the other one is a cooling fluid that goes, computers are literally immersed into this liquid to keep them cool. And that's very much more energy efficient than other ways of cooling. But they're both kind of...
Yeah, so let's jump into the transformers since you mentioned that. Now, first of all, I wasn't even aware there was liquid in transformers. So help us with the functionality and then how you're using a better material in there to help.
Also, for people that maybe are not that familiar with transformers, I always quickly explain it as, imagine like a pressure valve for water. So it balances the energy in and out of this kind of metal unit. You can get a level of power that's coming through the lines and transmission, and it's lowering the voltage so that it gets to your house. Or the opposite, where you have the generation of power, it will take this power and increase the voltage so that it can go through the power lines and get all the way to our houses. So a transformer is regulating voltage like you would regulate water pressure, if that's an easy analogy.
Yeah, thank you for that.
Inside this transformer, you have that difference of voltage that's happening, that transformation. To make sure that that energy is conserved and not dispersed, there's the avoidance of having any electrical things happening inside of the box, let's say. So this is an insulator that helps that there's no electric reaction inside of the unit, just the transmission in and out of the energy, and there's no losses inside. And then also the liquid acts like an insulator, of a thermal insulator, because of course there's a lot of heat involved in this energy transfer. So there's a solid insulator, and that all the equipment inside goes filled with this liquid that acts as another liquid insulator. Hundreds of years since transformers were invented, that fluid has been called mineral oil, so it's based from petroleum.
And so that's the more caustic liquid that has been in there traditionally.
Traditional incumbent solution, I call it.
Yeah. So what are you looking and replacing that with?
So what we do is a product called FR3, and that is a soybean oil base, but it could be other oils too. It could be rapeseed and others. And that is mostly the ingredients, refined soybean oil with a couple of additives just to make it work correctly. And that completely replaces petroleum. So at first, this has been around for about 25 years, slowly growing, but surely educating the market on it. At first, we had the number of people in the power industry just wondering, how can vegetable oil like do this same job? Like, are you sure it's even in a lot of our applications in bioindustrial, we have to do this initial work of educating people of the first barrier. Yes, it is going to work, even though it's vegetable oil.
Yeah, because I'm sure they're untrusting. They're like, it can't be that simple.
Scary. Change is scary, like it always is. And in the world of the job of those people is to keep the lights on. And that is crucial for our life now more than ever. So they take their job very seriously, and it's a very conservative industry that just needed to make sure that everything worked.
Well, they've got the track record of hundreds of years, right, Javi? So I understand why they would be skeptical, not unproven necessarily, but
at the beginning, for sure.
Yeah, definitely it didn't have the track record of what they were dealing with. And when you're dealing with power, you want to be sure this is important. This is important. The transformation, the transformer is a really important function, plays an important function in the power regulation.
That kind of links me to the thought of, with all of these applications that are now, that can be plant-based, bio-based, that we're always offering an alternative to something that was already there. So there has to be a push for that need, either from the consumers or from the companies themselves that want to do something better. It's an education process, but it's definitely a changing the way you used to do things and adapting to these new ingredients. So that takes the will of someone asking, which is stronger now, thankfully.
Absolutely. All right. Well, what is the other area that you're working in? That one seems just awesome. I mean, are there any negatives there in the transformer project?
Not really. In this particular case, this product also improves the performance of the equipment. It extends the life. It lets them have more power with a smaller unit. So there's less waste, there's less maintenance, there's no risk of an explosion. If you've ever seen, sometimes these transformers can overload and explode and have a fire. That doesn't happen with this fluid. If there was ever to be a spill because of a storm, for example, it wouldn't contaminate the ground. So there's really not a lot of buts to it.
That just sounds really great. And I'm not sure why we wouldn't just be making that transition quicker and quicker. It sounds like there are
I always
so
say,
many
if
positives.
everyone knew what we know, there wouldn't be a reason to not switch. So I'm thankful for this opportunity to educate, for sure.
Absolutely. I'm so glad to bring this to our listening audience. All right, what's your other project, your other area?
So the other one is a cooling fluid, very similar chemistry. So also highly based on soybean oil, over 95% based on soybean oil. And that fluid, you submerge electronic equipment into it. As you wouldn't imagine, if you put water into any electronics, right, they wouldn't work. In this case, just like transformers, there's a electrical insulation. So what it does by putting the computers into this fluid in some sort of a tank, immersion cooling is what it's called. It cools down the equipment, which you can imagine, the higher the computing power and the concentration of chips or these data centers that have multiple units, the heat that comes from these units is very intense. We all feel it in our phones or our computers when we use them at home and they have a little fan. Cooling or water is really not sufficient or not efficient. Sufficient or efficient.
Right.
And how much power they need to cool down the equipment. So it ends up happening that you need more power to cool down the equipment than to actually power them. So this provides a more effective, not only that it's a sustainable liquid in itself, but it uses much less energy to cool down equipment, which also, of course, helps in sustainability, less water use, etc.
Yeah. So is there an example that our audience might relate to of when you might need to cool down equipment like this? Is there an application you're familiar with where that,
This
so we might be able to visualize?
the specific applications that we're building, because this is kind of a newer category, the computing world. It's mostly focused on two now. It's just data centers. So all the computers that are in either tanks or drawers, kind of vertical, giant buildings of full of computers and data centers. Or also Bitcoin mining is another industry that as it develops with its ups and downs, but they also have a lot of concentration of computing power per chip because that's how they make the money, right? So those are two applications that initially we've started addressing with this solution.
Yeah, I really thought about the Bitcoin application because that is one of the negatives that I heard with that processing was the immense amount of power they use and the heat they produce. And
depending on the city where they go install either one of these Bitcoin miners or a big data center, cities kind of scared of how much power they're going to need. Their grid might not be able to afford that, or the water amount that they're going to cool them down. It's kind of a stress for the city, even though a lot of cities would want these developments to come and help their economy, right?
There are a lot of big companies providing corporate computing power as far as the data centers are concerned. I know at least here in the United States, and I'm sure across the world, where there's lots of applications for, you know, you to be able to help and maybe minimize some of the impact in that particular community. What has traditionally been used to cool these data centers or the mining? Has it been like water cooling or air cooling?
Usually air conditioning is the traditional
air conditioning.
It's a lot of energy. Water equipment that passes close to the computer through tubes, and then it's cooling it down as it flows. There's also the previous solutions of either these tanks or vertical stacking computers have been very either, again, petroleum-based solutions or very toxic with fluorides. I don't know if you've heard of the PFAS kind of thing that then contaminate water. It's a fluorescent fluoride, solution that is actually very toxic, and it takes, of course, thousands of years to disappear from Earth if it does contaminate, or it could generate cancer. High energy consuming or toxic for the environment and for people.
Yes, and once again, it just seems like there are a lot of positives to these alternatives and not really many negatives.
No, the industry only has to do some adaptation as they learn in the usage, like viscosity levels could be different or temperature range, things like that. That it's all about education. But if there's a push for the need for these better for the world solutions, then we can do it together. That's what Bioindustrial does. A lot of the products that we come up with are very much co-developed. Other partners in the industry that want to make their products, say, more sustainable, like IKEA, Bath and Body Works, Owens Corning. So there's usually an association of them saying, help me make my products better for the world. And that's where we collaborate on creating these things.
Yeah, and I love the word collaboration. Honestly, I think there's so much to be gained, especially when you have a situation or a user that has a product mix and they're looking for better alternatives, and you're doing the innovation and the research to be able to bring them options, and you can partner together. That's just such a powerful thing to do. Plus, Cargill is a very large company, and I do love to see setting the pace and raising the bar for other companies to be able to follow your lead, because you do have the resources to do some of this research and develop the whole different area that you're over and focused on, you know, these recyclable, renewable products that just have so much less impact or better impact on our environment.
We're calling them nature-derived chemistries, I think.
Nature-derived chemistries. Okay, I haven't heard that before. You heard it here on Future Foodcast. Nature-derived chemistries. Thanks, Abby. I love it. Well, what else? Is there anything else going on there in your area that you'd like to share with us?
There's a lot of fun applications that I'm super happy to share here, because it just blows people's minds when they can think of the possibilities. So from simple things like soy that goes into making candles. So that replaces paraffin. So you have a more sustainable candle that could go for every application, or waxes in general, right? There's industrial uses for wax too. That's one of the applications. There's a whole line that we call road construction, which is products to renew asphalt. So if you think of asphalt, it's very, very toxic as an element. So all roads that need to be refreshed, you can reuse that asphalt, mix it with this ingredient, and then kind of recycle that asphalt. So there's no need to regenerate that much more. And it also extends the length of temperatures when you can do road construction, especially in those cold places like Minnesota, where I am. So very important in some regions to extend that timeline of when you can work on our roads. There's oils that go into foams. So you can make a foam mattress, that not the full component, but it's like adding more of a plant-based ingredient to the formulation. Eventually you can make it more biodegradable, right? Like that it's faster for it to disintegrate into nature. So foams for shoe insoles is another application. There's oils that go into plastics. That whole family is called plasticizers. So you can make plastics more bendable, but also, again, as you add natural plant-based oils to plastics, you're making those plastics more biodegradable or faster to disappear from earth. There's starches. So when you think of the powder from corn, you can take that, and when you want to make recycled cardboard or paper, you grab that paper, they clean it and process it. You need to add this starch to make those molecules strong again and be able to have actual usable cardboard and paper. So that's one of the main applications for starches. There's also, it's a binder. So a binder, imagine you want to keep something together, but not glued together. Like the fiber that goes into fiberglass has starches. The fibers that make insulation for houses, like that pink foamy thing that goes, those fibers are together, but they're not stuck together. So that binder can also be a bio-based product that we have. So there's a lot of fun applications.
That's a lot. Those some really relatable applications that we've seen and we know. Didn't realize that there were natural alternatives that are being investigated. So that's very exciting that we might be able to, even if you can't get all the way there right now, just make a portion of the ingredient, that biodegradable piece. Like you said, it will shorten the amount of time it takes for that to biodegrade. Yeah.
The most common applications that a common person could go use and hopefully create the demand for are things, like I said at the beginning, our beauty business. When you think of shampoos and lotions, sunscreens, makeup, a lot of those are not offering a sulfate-free version or more bio-based content that you can look on the labels of some of these products. Yeah. And those are some of the ingredients that we provide with them.
Right. Plus, they're not going to be nearly as harsh to us. For example, our skin is such a huge absorber of whatever we put on it. So if we're using some kind of caustic chemical, even though it might be mitigated by other ingredients that are in that product, boy, I'm all for minimizing that and using something that has better ingredients, realizing that my body's absorbing it all.
And at the same time, as a consumer, I want to clarify this for your listeners. We're always very mindful of that. The performance has to also be there, right? You can't just replace things and then say like, oh, you're sacrificing your experience or your quality because of this. So having these ingredients perform the same or better as what they're trying to replace is another key factor of what we do, which I think hadn't happened as seriously before. You might think of previous efforts of either deodorant, plant-based deodorant, or soaps that you would feel, is this really doing the job that I want? So that peace of mind, I think people need to know that these are very much, again, in partnership with companies that do the final products so that you don't sacrifice your experience as a consumer with them.
Right. Well, and the other thing I know you talked about before was about you're not taking from the resources or the raw materials that would normally go into our food supply, for us to be eating. So we're not stealing from that at all. This is complementary.
Exactly. In the case of, for example, soybean oil. When you think of a soybean, 80% of it and the majority of the demand worldwide to cultivate soybeans is the meal, which goes into animal feed and other applications. The oil historically has been a byproduct of that real demand. And there's some and a lot more now uses in industrial application to make use of that byproduct that comes from that soybean. And it's not oils, it's the quality that wouldn't go into food. And anyway, like I told you also previously, Cargill is a food company, so there's no way we're putting in an extreme case the needs of the world to feed people would come before any of these applications. There's not, we can't realistically replace everything that petroleum does with bio-based solutions. That's why, for example, if you think of commercial transportation, cars, airplanes, and even is why that industry is thinking electric, right? Because there wouldn't be enough soybeans in this world to replace all of that fuel. So it's very specific applications that take very little, 3% maybe of that oil that's available for these industrial uses, for paints, for example. But it wouldn't be, like I said, all the soybeans in the world would not be able to fuel what gas. That's why we're all looking to different alternatives, right? There's these bio-based chemicals, battery and electrification for transportation. There's hydrogen that's now coming also as a fuel. So it's not a one size fits all. This is one of the options. As long as you know what options you have to slowly but surely replace petroleum, then we're all contributing at least.
Exactly. And I really like the point you made about the oil was traditionally, it's kind of like a byproduct that wasn't the reason. I mean, the soybeans are used exactly. So if you can find uses, in the sustainability ecosystem, trying to use all of the resources that we have in the best way we can. So it seems
less
to
waste.
me, yes, this is a great way to innovate with that oil that's a byproduct of the other processes that the soybean is going through. I just love the whole concept. It's really great. Well, is there anything else you'd like to share with us before we go? It's such a rich podcast full of information that's new to me, I know, and I'm sure to a lot of our listeners.
Biggest thing that I would love for people to remember is that none of this change is going to happen if we don't ask for it. If we don't ask for the little bit that you learned today, help us share that there are alternatives for all these things that maybe you didn't even think of before. The more that we demand them as users, as like consumers of everything, right? Citizens of this world, the more that we ask for those things to happen, the faster they will. And then hopefully we have hope for the future generations. So spread the word that there are alternatives for some of these things. It's like a fun topic overall. The more you research, the more you'll know. But for sure, prefer things where there's like a bio-based component. You can do your part by just preferring those options so that there's an incentive for these companies to keep doing it.
Yeah. Thank you so much for sharing that reminder with us. And please leave us some comments if you enjoyed this topic and would like to hear more. We at Future Foodcast want to know about that. Javi, thank you so much for being with us today. I also want to say, look out for our next episode. Like us, share us, and subscribe so you're notified whenever we drop a new episode. Until next time, I'm Pam Line-Miller.